Okay, so how in the heck do you do these projects? You asked for them, so what am I getting at when I do this for the class? So right now we're on the midterms, which are projects. We're on that web page. I'm just going to try to maybe walk you through what we're getting into this term. It's maybe different from what you've done in other classes, but it's kind of the unique thing I do for a class, and a lot of students appreciate at the end of the term, because they mostly have something to put on their resume at the end of engineering school, and they learn a lot of cool things along the way, much more than homework, as I've been told. Okay, so the point of the projects is we're gonna play pretend. We're gonna do a little bit of role playing. I like board games and RPGs myself, so I guess that's where I got inspired to do this. And I think it's more involving if there's kind of a story to follow. So that's what we're going to do. For these two projects, we're just going to do a little role-playing and pretend first pretend we're engineers. And then, later you'll become one, and hopefully you like it. I mean, that's why I'm getting this degree. But I'm just trying to, come up with little scenarios where you can maybe get a taste of it and show your skills. Okay, it's kind of the same thing as all the pages, right? There are these drop-down menus that you should probably just read once, and then you don't have to read them again, so that way you don't do so much scrolling. So, file submission guides for projects. Instead of a file that you do for homework, for the projects, what you're going to be turning in to me is a zipped folder. Okay? So, to zip a folder, click this link. I imagine you can figure out how to zip a folder. What's important about projects is instead of just turning in one file, what you're turning into me is just a folder with your last name attached to it. And it will go into it's submitted to a full file system where it's like, I know which project it is. I just ask you to put either your last name or your team name on it. And what's important about what's inside of that folder is that it's just 3 files with the exact same names for whatever your team is or your student is. Okay? So what you're going to submit into the project this time is not one file, but a zipped folder. And that folder will contain a file called presentation, which can be a PowerPoint. It could be, it could be a YouTube HTML link. It could be an MP4 recording, however you want to record yourself presenting. And we'll get into that later. A calculator, and this is really your analysis calculator. So it's sort of the file that you use to do your engineering analysis for. Okay? And that can be done in any real way you want to. So I have some, you can make a Python file, a MATLAB file. I highly recommend Jupyter notebooks. They're really clean and easy to understand. You can do a Julia file or a Julia notebook. You could even do a MathCAD, an Excel spreadsheet. It's kind of just like your little calculator that lets you calculate all the quantities and lets you change parameters to make engineering decisions. And then a report, which is essentially, it's going to be, it's just an executive summary. So, I'm just asking you to sort of write up and make a good sort of hit all the neat points, make it look good, make a nice, clean-looking document. And that could be a PDF. It could be a Markdown folder, actually, if you don't know how to write Markdown. It could be Word. Again, you have a lot of freedom of how you want to make these files. What's important is that you just are doing engineering work somehow. And then what also is in this folder you give for me is a subfolder just called data. And the data folder is something that I will provide you for each project. So you download my zip file of data, you do things to it, and then you can just send it back to me. And I ask you to do that because if some of these things, if you want to do a Jupyter notebook, it would actually probably call to one of these files. So you probably would set this up anyway. So I kind of just want to see if you monkeyed with the data at all. Kind of a check on my end. So here are just 2 examples to help you learn. Let's say I did my own type of, if I wanted to do a solo submission for these projects, what I would do is I'd make a presentation in PowerPoint. I'd probably make a calculator in a Jupyter notebook because those are really hot and I think they're just awesome tools. I write in LaTeX, so I'd probably have a PDF. I'd download data. So my first project I would submit, I would just write Molar, zip, and then I would submit to the Google form. Okay, then for the second project, if I didn't like doing it by myself, the calculations were easy, but I just thought the workload of making a quick presentation, making a calculator report, it was just too much. I feel like I just didn't get enough of the tools on my own, so I wanted to join a team. So then I joined a team. We call ourselves Mario Brothers. And then we submit basically the same thing. All that's changed is I just now submit a folder that's just called my team name instead of my last name. Okay, so importantly, hope you all noticed that the only thing that changed here is the name of the folder and the file extensions. Keep these things the same. How you're graded on these files. So you notice what you're turning in are 3 files, right? And each file essentially will get a grade for its project. So each file is 30 points. So your presentation, it doesn't have to be that long, right? It can be just a quick YouTube video of you with some slides. It could be you even like walking through a Jupyter notebook. A lot of people do that nowadays. The idea is that you as like a project manager are walking us through the analysis and showing us how to do it. So importantly, you're kind of giving a quick presentation to Imagine non-engineers. That's kind of the challenge on this. You get 10 points for the clarity of it. I'll give you 10 points for essentially slide design. I put that there because sometimes you get a lot of slides or whatever that it's just a white screen with text on it. Don't ever do that. Don't do that, please. And then you get 10 points of recommendation. So that's kind of summarizing what you thought you learned. You know, what's your engineering decision based on the types of problems you look at. Calculators also get 30 points. You get 10 points for the values. So I essentially know the values where they should be around based on reasonable assumptions. Again, if you're doing good on the presentation, I'll see like what your assumptions are, and then I can go, checks out. But they got to be in the right values. So that's, you know, this is the difference of your values are like, it'd be like if you predict 200 kilopascal for something, and I know for a fact like at least it's like 5 kilopascal. You know, you're going to get docked on values. Usability is also something important. So usability is when it comes to engineering, you have to be reusable in your work. So, you know, when you make these types of calculators that like, you know, take all the input data and like, output some sort of number that we make decisions with, they got to be usable. So just, you know, be cognizant of that someone would have to pick this up later and use it. So an example is if I have to spend like 30 minutes trying to figure out like how on earth this thing runs or what it does, you know, that's bad, you know. And it doesn't take much. The calculations are really easy. It's kind of the formatting and telling how you're calculating that's really important. And extendability. This is essentially what I do is I'd like to see if I can change data and if the outputs still of whatever you're doing work out really well. It's very important in engineering, right? You always want to tweak parameters and see what's going to happen if you change the design. Report. So report is again just sort of an executive summary. And you get 10 points for these 3 things. So you have syntax and voice, figures and results, and design. So syntax and voice is just, you know, just sound professional, right? Just sound like you are an engineer. I know I'm jokey on this website because I like to sort of, you know, have fun with the students, but, you know, that's because you are going off into career stuff, so that means you got to sound professional. So just, you know, work on that and try to develop your own voice as an engineering writer. I say figures or results because you don't need to put a figure in your executive summary, but, you know, if you feel a figure does a great job summarizing it, you know, it's really, it's good. Or just sort of being very concise and clear with the results of your analysis. That's key. And then design. Make it look pretty, right? Just a raw text file. It's a bad document. Documents should be inviting how to read them. Okay, so then next you have group submission guidelines. So you can just do all of the project yourself as a solo student if you wish to, or you can get together on Slack and make a group and do a group submission for these projects. I highly recommend that because you get to experience and practice the challenges of real teamwork in engineering. Okay, so for a group, there are 3 distinct roles you can select. You can be a project manager for a group. There's 1 project manager per group. Okay, the project manager is on the line to make that presentation file and has to be good. The one caveat of the project manager is since you're only on the line to make a presentation, is you get the lowest grade of all 3 files. Okay, so if they're right, and that's because you're the manager, right? So if the presentation file is like really bad, then you'll get that bad of a grade. But if you did really good at your presentation, but the calculator is just awful, bad grade. If you get again really good presentation, really good analysts, but the scribes, right, the people that did the report, it just was like toddlers wrote it, get a bad grade, right? So you are only as good as your worst team member. So that's really and again, you're only on the line for this presentation, but as a manager, that's what you take on, right, is you have to, you know, build your team up and just kind of make sure they're on task. Analysts, you get 4 analysts to make this calculator document, right? So it could be an Excel calculator, it can do whatever, right? The job of the calculator is that it takes the data that I give you and it outputs numbers that we make decisions on, okay? Just descriptions on how you do really good on this. So you have a maximum of 4, minimum of, I guess, 1, right? and all analysts will share the grade of this file. Okay, so right, the file of the your calculator gets a grade, and all the analysts will share that grade. So you all should work as a team, just as analysts alone. You're not in the line like a project manager. Scribes, you get two scribes for a report. So that means 2 people will just take on the responsibility of writing this document and making it look nice. I will warn you that before when I teach this, some people will try to just sign up for scribes because they don't like math and they're just trying to get through with an easy pickings, and they'll get bit by that because they're doing scribe work when they probably should have done analyst work. They're not good writers. They don't really know how to make a good document look nice, etc. So they get hurt on that. So I'll just say I left it as 2 because some people in engineering are far better at telling stories and doing the writing part, so I kind of want to highlight that in this class for projects, so that you can succeed as an engineer without this stuff or that stuff. You can just be really good at, writing and telling the story. So please don't sign up for this if you're just trying to game the system and not do any analyst work, right? This is kind of a hard gig to do because you really have to tell everything and very well. But again, I leave it there. I used to have maximum of 3, but I went it down to 2 because the good scribes I had gave me great feedback saying we all were really good, but we're just kind of butting heads a lot, and 3 was too much. So I raised the analysts to 4 because some people were going if we had 4 analysts, we could do a lot better. So this is kind of a new setup for this. Okay, and then as always, I have possibilities for extra credit. So for extra credit, same kind of thing, and these kind of are big ones that I put for projects, right? So if you do all of the calculator adds a Jupyter notebook, you just get automatically 3 points of extra credit. So that's like an extra, right? That's an extra 10% extra credit you could get. And I do that because I think engineering schools should be teaching Jupyter a lot more, or notebooks, and it's also free. So that's another reason I did this. Also, they're just kind of it's a neat thing you can kind of say after you graduate. That you know how to do, right? So all extra credit I give in classes, I'm trying to sort of give the student a chance to turn a class into something that they can learn a new skill for. That's good for the workforce. Okay, and then for scribe, this kind of a scribe thing, you can also do the report as a website, kind of like how I made this website. That would be that'd be awesome. I think I might raise this extra credit because that's like a huge endeavor, but that would put your scribes to a whole bunch of work, and it'd be really cool, I think. So I might raise that extra credit, right? The idea of the report of your project is to make a website that I can visit and then peruse around. That'd be awesome. And then imagine you go apply for jobs with this website. You'd just be killer, man. Just super killer. Okay, so that's all the details. So I kind of walk you through that. You can read all this junk and garbage I wrote just to kind of make sure it's clear in my head. Hopefully it's also clear in your head from it. It's also just good reference to generate all this content so you can reference it. Okay. So then you scroll down and we get to the actual projects and describing what the projects are. So there's 2 projects that are separated by color, right? So notice this is a gray screen and then this is yellow. So you kind of always know which one you're at. Okay, so the first project is going to be the real-world piping system. So we're taking all of the equations we learned about friction factors and pressure losses and materials, etc. Bunch of equations. How the heck do I know how to use these things? So this is kind of a scenario where you might need to go into that toolbox for that Darcy friction factor, that Reynolds number, etc., and start calculating some things to give your manager an answer to a design question. Okay, so for this one, in all of them, this is kind of right. Same thing. Only click this fill out form when you're really ready to submit. There's no real reason to fill out the form now. This essentially is just a portal, as you can see right here. This is just brings you to submit the folder. Submit your zip folder. So only click that when your project manager, etc., is ready to submit. Other than that, there's no real reason to click on that link. Okay, so first there's a kind of steps to these projects. So first step is always download the data folder. As you can see, click this link right here, and it brings you to a way to download a zip folder. So so here's Open Extractor. If you're in Google, I just do this, right? Click the download, boom, it's downloading. Open this. Extract all, boom, and I got your data. So the data has invoice pipes. So here's all the little data sheets that I have, and then there's also a README, which is a Markdown file. So I have Typora, which lets me read Markdown. If you don't, you can do read in Chrome. And this is a description of really all of the files in the data. So read that because it lets you kind of just describe what's exactly in each data file, and then you know what to do with it. Pretty important. That's how you download the data files. That's really should be your step 1. Get the data. Okay, number 2, get to work, right? Somehow manage and just come up, figure out ways to get numbers to be able to make answers. And then 3, fill out form. Okay, so after you get the data, then go ahead and kind of read this little story I make for these projects. So this story is an OHSU contingency plan. So this is this idea that we're on like a fault line in Portland, so like there's worry, right? For a large city disaster. Something. Let's think. Again, I make these things up because I'm just trying to come up with like a fun game for us to play. So they're not the most realistic, but they're certainly more than like a random problem you might encounter, right? So kind of bear with me on these. I certainly am always open to better project ideas. So for this one, essentially it's just an email from me, your boss, kind of giving you a rundown, kind of, simple path on things. Not simple, but they're kind of direct paths on what I want you to do. Take all that data, and I'm asking you, right, how much will it cost to run this pump to run water from a reservoir up to OHSU? Okay, and then I want a cost increase for additional bed. Other things, it's also good to think, if this is the important thing of a calculator, right? Tell me if I can save money if I change all of the pipes in the problem to concrete to commercial steel. So come with that. Also, like, which reservoir should I pick? So in the data file, there's a bunch of options on reservoirs to pick, and then you should tell me, what's a good one, in terms of cost, really, right? It's up to you. This is the project point of it, right? Use your engineering brain and like come up with solutions. Kind of a fun thing too. I want you to really figure out how high up. What's the difference in height from the reservoir that you pick in the city of Portland relative to OHSU? So you kind of do some digging. It's kind of fun to do, I think, like understand that engineers can Google a lot of things to make numbers. So do that. Get some experience doing that. I think it's really fun and kind of, the best part about it, So this is, an introduction to maybe some of these things. And once you get over, like, dinking around with data, making calculators, I think you're kind of ready to start on and off to roll in this second one. Okay, so then you go to the second one. The second project we're going to do this term is sizing for pumps. And this is just a very common thing, right, that you got to do as a mechanical engineer, right, where you've got to, like, get dimensions and get data and get things involving your pump and figure out, like, which pump should I pick, which filter should I buy, do the lines matter, does the system resistance matter, et cetera, et cetera. So one of these things that's crazy about that is just the amount of data available when it comes to picking pumps. So you will feel that when you start this project. So what are the steps for project 2, right? Well, clearly, download the data file. Same situation right here, brings you to here. I give you a zip file. Click that button there. It's going to repeat, right? See how it's -1. It's just because there's data already in there. Okay, so same situation there. Okay, get to work. And the fun thing about this one, I think it's fun. So other students thought it was fun too in the past, is notice how here I email you kind of like a direct kind of 4 bullet list things of what I want from you and how to do it. For project 2, what you have are these 3 emails that are from your internal company, right? So in this one, we're pretending we're engineers at Fake Trucks Incorporated, and we're looking into a new front cab design for an 18-wheeler. And we have some data from the wind tunnel test, and we want to incorporate that into the engine system. So there's a lot of tubing in engine systems, etc. But what's the challenge of this project, I think, is just kind of getting that sense of, okay, people are talking in your technical firm, and like there's like brewing ideas of some project or engineering decisions that can be made, and then I want you to step in and maybe just come up going like, I know what to do for this. Hey, let me do this for you. We can come up with something. Again, it's all kind of buried in these emails of like what you probably should do, but it's a good opportunity to maybe sort of like stretch that muscle of like developing problem statements. In your textbooks, you always get this wonderfully nice said problem statement, and that's just a disservice for engineers, right? Engineers come up with a problem statement. I always provide like a figure for it as well. Now, I have a little warning down here, really describing to you that like you're gonna, for this project 2, you're gonna have this immediate like, this just seems impossible. Why? This is not fair. But it's just a warning, right? That the whole thing is, here I just shared like my own little journal note diary. I have these goals of what I want to teach you with this project, right? So keep that in your head. I think when you come to this project, and it should carry you along. I asked previous students, and they all kind of agreed, like, it's just this thing they got really scared of when they first started doing this one, but if they kind of just hold on to some key things, they get somewhere. Okay, so the 4 things I'm really looking for you is this idea of planning calculations before attempting them. And the point of that is, right, if you don't plan calculations, you'll get lost with this. Number 2, going from experimental data to constants that you use in engineering calculations. A lot of times we're just given these numbers in the textbook. I kind of want to show you like some examples of how really getting those constants is critical so you can do napkin calculations. It's a fun thing and amazing. 3, I want to show you like engineering optimization of design. Sometimes can just be checking a bunch of cases if you have a really fast calculator set up for your design. So it's kind of, I want you to experience using like a calculator type thing you use in part 1. Not the same calculator, but really using it because you're just going to tweak parameters and see like, does it cost more, does it cost less? And number 4 is like a little extra credit thing I was trying to do, and I try to do it with always the last thing in the project. And that's like I was trying to give you an edge of other students that are graduating, at least from our college, right? So I picked 3. I was thinking like, could we do some like quick machine learning? And I was like, that's way too hard, not even involved. I was like, how about using pandas? I considered that one for a bit, but again, I didn't want, it was almost too much because I didn't want to require anyone to use Python, so I just settled on JSON data, right? It's a very common form of data used nowadays. It's like human readable, and I'm just trying to demystify it for you guys or girls, right? I'm trying to, instead of just having CSV, right? I just want you to come out of this class and this core and the curriculum, right, where you will know what JSON data is. Not just a CS guy, you will also as well. It's not that crazy, and it's pretty easy to read. Okay, that's a lot, but I'm just trying to introduce these projects, how to do them. Again, you can read over these as much as you want, but again, the other thing I want to point out is like, see how there's no arrow? Please know to click these emails to read them because they're pulled down. Right, so please, you can't see the arrow there, but make sure you actually expand these and you can see them. Again, this may seem a little, maybe too much, but I just, if there's any board gamers out there or, people that like RPGs, I find it very easy to learn something if I can make some sort of story to it. So help me learn a lot, pick up things quickly. So that's projects. So you could just read out things I read yourself and ask me questions later. Hopefully this might clear up questions of like what on earth we're doing with these projects. But that's why I wanted to make this video, because I usually get a lot of questions about what's happening with these projects. So again, always reach out on Slack to go like, how do I do that one thing? More than happy to help. But yeah, hope that project low down. I gotta stop talking.